Welcome, everybody, to the rerun of Class 2 of Cohort 2 of the African Air Foundation. Uh, our goal is to create AI champions and people that will go on to do incredible things, be founders, be entrepreneurs, be product people, building various AI systems, right? So I'll be sharing my screen shortly. Again, I've said this earlier. This is the rerun of class two. So if you missed class two, yes, this is important for you. Or if you just want to, participate in this just for the fun of it, again, that you're welcome as well. But it's for mostly people that missed uh, class two. Class two, there were technical glitches with class two recording, so we lost the recording, and the people that could not participate live could not catch up on demand. And that's the reason why we are having to, rerun class two so that it could be properly recorded and access to the recording could be shared with people that are not able to participate live. So welcome everybody to the class two rerun. I'll be sharing my screen and taking us through the deck, which you'll be having access to shortly. Yeah, and then you'll be having access to the deck after the class. So all right. Hold on one moment. So let me know once you can see my screen. Allow to talk. Allow everybody to talk. This should be default. I don't know why this platform has to. Hi, Babatunde, you have your hands up. You can unmute and go ahead with your question.
I can see your screen, so.
Right, thank you. Thank you. Awesome. All right, so let's get into it. So we were working on this particular document. We were working through this particular document from class one, but we could not finish. We established that AI is nothing new. It's just reinvented, you know. We discovered a newer architecture, a better approach to doing things, and that is what sparked everybody's interest in AI again, right? That's what sparked everybody's interest all over again. AI actually started in 1956, where the concept was being tossed around where, okay, instead of programming computers, can we program intelligent computers instead? Instead of learning the rules and then writing the rules into the program, can we write softwares that will learn the rule and do what they need to do? We don't have to teach them the rule. They learn the rule and then they use the rule to carry out task. That's how it started. And for a period of about 10 years, there was no progress. That's because in the 70s, the PC era emerged. Uh, Everybody was interested in, what Intel was doing, what all the chip makers were doing, and Apple and the likes, IBM. That was their era. So there was no funding for AI research. AI scientists were hungry all this period, right? And then into the 90s, there was renewed interest again. And that's mostly because of the successful PC era. So now we had more sophisticated PCs that could hold a lot of, they could process more data. We have, better, um, we have better, what's it called now? Excuse me, what's distracting me here? We have better processing power, better storage, better, connectivity, and all of that around the 90s, right? Because now at that point, we've seen everything that we needed to see, on the emergence of PC and different type of new computing systems. So after that, we got into this deep learning era in the 20s into in the 2000s, early 2000s, where the fact that we had new data created by this the spark of internet. Internet started within this era, but now it became mature around this era. Amazon launched, Google launched, PayPal launched around this time as well, right? And now all that created massive amount of data. We had access to massive amount of data that made AI interesting again, which sparked a reemergence again in 2000, where newer AI architecture came through, and then that was the new big breakthrough. After the 2000, AI went to bed again. There was another, it wasn't precisely winter, we can't call it AI winter. People were using AI in different things, banks were using it to do credit classification. Should I lend money to this person or not? Should I do this or that, right? Uh, Social networks were using it to decide, should I show this ad to this person or not? Should I show this content to this person or not, right? All those kind of stuff were there. So it wasn't necessarily AI winter, but it didn't see widespread application. AI is only known to the geeks, the people with Googles and my big textbooks, right? That's at that time, around this era, it was only known by the geeks and the computer science professors and engineers. But in 2017, everything changed when the everything changed when the scientists working at Google invented a new architecture. In 2000s, what happened was the invention of a new AI architecture, the recurrent neural network and convolutional neural network, right? Now the same thing happened again in 2017, where a new AI architecture was invented. And this time it is called the transformer AI architecture, right? What the transformer AI architecture allowed us to do was immense. It was like difference between night and day in terms of what we had and what's now possible, right? So the Google guys could not productize it. Of course, unfortunately, Google was slow in terms of productizing the innovation, and that is what ChatGPT did. ChatGPT came, the OpenAI team came, carried the research paper that was published by Google and turn it into a product. And that's the ChatGPT you're using today, right? The same architecture, ChatGPT is text-based, but now they tried the same architecture. They tried it on audio. Wow, it's led to amazing discovery. Now you have some people doing AI models that can actually create music, AI models that can, turn text to speech in a way that was never possible before. Now you have AI models that could, do incredible speech, impossible things with speech, right? Now, the same architecture that the Google guys originally did it on text. They used textual data, right? And that's what the OpenAI guys did with the first ChatGPT, right? But after then, they tested it on video. Magic happened again. They tested it on other data. Hello, please, can you raise your hand before you unmute? Who is so we don't disorganize the class? Latif, do you want to say something? Can you mute yourself, Latif? All right. I'm giving everybody the opportunity to be able to talk, but please raise your hand to talk. I think we have more people join not too long ago. All right. So you can talk if you want, but please signify before you say anything. So yeah, the the same architecture was used on different domains of data, and it just kept hammering out the whole thing, right? Of course, the architecture had some changes here and there, with some changes in the architecture to adapt to the domain of the data, to the modality of the data, but the architecture kept nailing it, right? And now we have text to video, we have text to images, we have text to audio. Mute, please. Can you mute yourself? I'm going to have to disable you if you are, causing disruption, unfortunately. If you mute yourself, or else I will disable you from being able to speak, so we don't distract everyone else in the call. All right. So now with the transformer architecture, we were able to do incredible things. Yes, transformer started with text, but when we saw what was possible with textual transformer architecture, we did the same was applied to audio data, magic, video data, magic, even genetic data, different forms of data, financial data, magic, right? And that is, where AI started becoming more mainstream, because now you can do a lot of incredible things with AI that you could not do before. And now that's when everybody started hearing about AI, right? So it's been around for some time. It's just it's a renewed ignition. The interest that recharged the interest on AI, right? So we spent some time during the first class talking about this. These are the things, some of the things that we'll be working on. Focus area on healthcare, on natural language, on financial data, on smart home automation. I think we'll discuss that. We would be scrapping out some of these, like smart home and autonomous vehicle. The AI is quite simple, right? It's quite straightforward to write, but because you would not be able to test that, we just kind of like narrow it to things that we can test. And the data can be challenging to handle beyond what you would have access to. So e-commerce, recommendation engine, manufacturing robots for QA assessment, cybersecurity, to know whether network stuff is a threat or not, virtual assistant, and then also in agriculture. So some of this data we have some of this data, and then we'll be walking through them during the course of the cohort. If you were part of the third class that already held last Saturday, you would already see some of these examples where we, walked through home prices, prediction of home prices using regression model. Regression model has been around for some time, but we just started from something very simple, and then it's going to increase over time. So yes, also in class 1, we talked about a projection, how AI is going to take over the world. AI is going to create a new $15 trillion economy, and this is, out of 15 trillion, 15 trillion is 1 million multiplied by 15,000. 15 million. Yeah. 1 million. 1 million multiplied by 15,000 will give you 15 billion. All right. So 1 million multiplied by 15 million. So AI is definitely going to create a new set of AI millionaires. You don't need up to, you don't need more than 1 million to live comfortably, an ultra rich, comfortable life. If you can create value with AI, right? If you can solve some problems with AI, you could, potentially be part of those 15 million folks that would, share from the, new $1 million wealth, right? It could be 15,000 billionaires, who knows, right? But we'll see. So, but our goal and our aim, aspiration is to ensure that people from, the African Air Foundation are able to participate. All right. Of course, there will be job transformation. We don't say job losses, we call it job transformation, right? A lot of jobs will be gone and then new ones will be created. The new jobs that will be created will be highly paid, heavily rewarded, because it will be highly skilled job. Those jobs will be highly skilled, and that essentially would mean that it would be high reward set of rules as well. We've already started seeing people earning, you know, uh, we've already started seeing people earning hundreds of thousands of dollars being prompt engineers, right? Prompt engineering is a very simple thing. You can do it if you understand what is going on within an AI model, right? But that is what we see today, where just by prompting a model, you're earning that crazy amount of money. That's something that was never possible before. Also, just like job transformation, there will be industry transformation, right? Some businesses will cease to exist. They will stop existing just because AI came to be, right? And those business models will, the businesses that are agile in transforming themselves would be able to, of course, create new opportunities, because now AI will also create new business models that were never possible before, right? That is what will, happen here. So yeah, we spoke about this, and then it will create economic efficiency, and it will create economic inequality as well. Inequality, which is what we're trying to avoid. I always point at the fact that the IT revolution is everything around the emergence of PC, internet, and all of that around the 70s and 80s, which matured in the 90s. The IT revolution saw immense wealth creation, uh, up to between $5 to $10 trillion get printed in new wealth every year, just from IT alone. Right, that money is shared by the Google that earns about 300 billion annually. The Microsoft that earns maybe 350 annually. The Apple that earns about 400 annually. The Amazon that earns about another 400 or something annually. Who else? Intel earning about almost 100 annually. Cisco as well. Huawei, ASML, right? This is real amount of money going around, but Africa has 0%. It's actually 0.001 whatever, if you do the calculation, but essentially 0% of the IT wealth creation. And the reason is because we were observing when the world was land grabbing. All we were doing was, checking, oh, what's going on over there? We're not doing anything, right? The world was land grabbing. Microsoft held productivity, Office software and all of that. Google held search and defended that terrain, right? Cisco, Intel, all of them, they were land grabbing. But what happened in Africa is that we didn't do anything, and that is part of why Africa is, the way it is. But now we have an opportunity to create new, between 10 to 15 trillion in new wealth. Every new revolution comes with new wealth, that gets generated. And this one will not be different. It's already started happening, right? You can see it already. Yeah. So our goal here is essentially, reduce the likelihood for that economic inequality that's likely to happen. And the way it will happen is that if you are able to upskill, you would be part of the, ones that will take the opportunity. If not, you would be part of the folks that will be disadvantaged. Right. Of course, economic efficiency and cost reduction. Now, if it takes 50 people to deliver $1 million revenue before AI, it will take only 5 people to deliver $1 million revenue now with AI. You can see all that's happening with AI that can code softwares, AI that can do customer service stuff, AI that can do all these things, right? So all this will change the game massively. So we spoke a little bit about different modalities of AI: vision, audio, and then text, right? And then multimodal that can now change between modalities, right? So these are all applications under vision modality, text modality, and audio modality. But now you can even now change between the different modalities. So let's get started here. I think this is where the meta meets the road on the class 2 conversation. So we spoke about the differences between AI and human learning. How does AI learn? Intelligence. For you to be intelligent, it means you've learned, right? Human intelligence and artificial intelligence. What are the differences between the two types of intelligence? Number one, AI algorithm can convert data into numbers and extract pattern at a speed that surpasses human capabilities. Right? All an AI model is just a bunch of numbers that represents the information contained in the data they are trained on. Let me say that again. All an AI model is a bunch of numbers that maps or represents the very information that is contained within the data that they are trained on. So if they are trained on verbal textual data, there are some specific information that's contained in that data. So the numbers after training maps to the information contained within the actual data. If it is video, the same thing, right? It doesn't matter the modality, but an AI model is just a bunch of numbers, right? In a matrix form, right? So the number, you cannot assume those numbers. You cannot get there by chance. You can assume those numbers. So to get to those numbers that are within the models, that is what training does. So by the time you train a model, it's now it now arrives at, okay, what are the numbers across the different dimensions of what is represented within that model. So that the process of it getting fitted, is the process of it learning and extracting pattern. It's extracting patterns within the numbers, right? That's how it works. No matter what the kind of model you're trying to build, this is what happens, right? As a matter of fact, the line of code, if you're writing code to train a model, the line of code to train an AI model is just a line that fits, right? The rest is the data. Handling the data, massaging the data, engineering the data, and all of that, right? But once you call the dot fit function, depending on the AI model you're building, right, it may be different. It will likely be different for transformer models. But the same logic, a bunch of data, convert those data to numbers, convert those numbers, now use those numbers to extract patterns within the numbers. But human-based learning involves slower cognitive process, requiring time for comprehension, reflection, and decision making. You know that what you did yesterday was wrong, right? It is that understanding that has led to you wanting to make a better decision today, right? You have to reflect. You have to reconsider. You consider different viewpoints. So all these things require time and comprehension. It doesn't make it bad. It's just a different type of intelligence, right? It's not as fast as you know AI based learning. And AI can learn the entire data that is on the entire internet in few months, but you cannot do that. It takes what you've known today has taken your age to learn it. You can imagine that. So moving on, AI-based learning is susceptible to biases present in the data it's trained on, right? So if you train your AI model on data that shows that maybe you own a bank, you used to, you used to issue loans to folks. You used to issue loans to folks. But now you want to digitize it. But in your data, you've never loaned money to a South American before, or an Asian before, or an African before. Only Europeans and Americans. And then that is introduced into the training data, the race of the folks or the people that want to borrow money from you. The chance that the model will say never lend money to someone that is not Asian or someone that is not European is high. That's what the model will likely do because I've never seen the data. It's not represented in the data. And this is why data representation is very, very key. All the models that we have today, they are mostly even in English. The LLM models are mostly in English. They can do a little bit of, multiple translation to other languages, but it's not as good. It's only English that is the best. By the time you're trying to do English to Chinese, oh, forget about it. It's not going to be as good. So that's why it is important for you to understand the biases that are not ethical so that you remove that data within your training data. Remove all those elements within your training data. And that's like things like sex, things like race, things like religion, things like political beliefs. You don't want to, create, you don't want to fit people across those, polarizing dimensions. If you do that, your AI will be biased. The AI is essentially learning the bias that humans already have. AI tool we pick it up and then we exhibit the bias and even amplify it. It has learned that, oh, okay, so you guys already have biases. Oh, don't worry, I can see it. I will help you, amplify those biases, right? So that is what point 6 is talking about. And for humans, human-based learning, on the other hand, allows for critical thinking, contextual understanding, and abilities to question and challenge biases, leading to a more nuanced and adaptable learning. If someone asks you to go to a bank and break the door, break the wall, and get into the bank and steal money, you have judgment. You are taking contextual understanding and critical thinking into perspective. By the time you critically think about it, you know that no, this is not the right decision for me to take, right? But that's not the same. That's not the same for an AI model. There's an AI model type a training type called reinforcement learning. In a reinforcement learning, what you're trying to optimize for is to you have a target function that optimizes for a particular scenario. If the target there's a word they call it, it's currently eluding me right now. If the target function um, that your reinforcement learning optimizes for is to eliminate, human in the most effective way. It will do that to figure it out. You know, so the target function is that use the minimum bullets to find the most effective way to kill. If you can start from the toe, shoot the toe. Of course, in a simulated environment. Realize that the person is still breathing. Shoot the knee, shoot the you can run that simulation millions of times till it finds a place that it will shoot that the person will die immediately. It's a very realistic AI problem that AI can solve. That's a very realistic one. You could even say, okay, find a way to kill without using any bullets. You will find it. If you try it millions of times, till it finds the best way to accomplish that target objective, right? But human beings, that is not going to be a noble direction for you. To doing that will not be helpful, right? So next one, let's move on quickly. So AI based learning currently can't convert emotion into numbers. So we have I'll be asking some questions. I'll be throwing some questions out now. So you can use the I think is it the chats? I think you can use the questions and answer the Q&A part to answer those questions, right? If you want to type in there, that'll be good. Okay. So AI-based learning currently can't convert emotion into numbers to augment its learning input. Therefore, can't process emotional patterns or find emotional patterns. That's what I was trying to say there, right? This is changing really quick. This is changing really fast, but it's still not as good as humans in terms of doing that. Sorry, let me put off this alarm. 1 minute. All right, sorry about that. I had to quickly put off the alarm. Okay, so even though this is changing really quick, but it's still not where it needs to be. For human beings, you don't have to even say a word for you to. There's something called body language, right? Body language by when you speak or when you communicate. They say it's only about 40% of your communication that is via the words that you speak. The rest is via the body language. AI cannot learn from that, for example, today, at least in an effective way, right? It's not because remember, we convert data into numbers and then use that during training. We convert data to numbers and then use that to find patterns within the numbers. That's essentially what AI does all the time. But as I'm speaking to you, my tonality, my pace of words, my countenance, the way my hands are, my legs, or all those things could be interpreted to provide richer information and context to what I'm speaking about, right? But all an AI model would pick is the voice or the text or the video streams, just within those modalities that are standard. But life is beyond those three modalities: text, voice, and video, and audio, right? Images more like a video, right? Multiple video in a stream. But real life is more than those modalities, right? Even though it captures a big chunk of reality, but it is more than that. It is more than that. In the last class, the last excuse me, the last class two, I was given an example, especially for most people abroad. They don't correct, you can't beat your child, right? Or else the government will take your kids from you, right? So because you cannot beat your kid, you have to, invent new ways of showing them that what you're doing is you don't approve of it, So you can turn your head, frown, or give them one look, that very Yoruba, local Yoruba look, and they will get the idea, and they will likely, correct. Know that okay, you don't approve of their current behavior. An AI model cannot, pick on those data because it's challenging to convert those data forms to numbers. If we are able to convert all the non-verbal cues and empathy and all of those things to numbers, it's game over. AI will show the biggest emotion that you've ever seen. AI will show it. The only challenge, the only barrier to that is just in terms of, how effective can you convert emotional cues into numbers so that AI can find patterns within them. That's really just the issue there. But let me ask you, you can use the question and answer box to respond to this. Even as incomplete as it is, so there's something called the emotional map, emotional wheel. There's something we call emotional wheel. Have you seen this before? Have you seen this before? If you were to use human emotion as part of training data, if you were to use human emotion as part of training data, how would you convert these emotions to numbers so that it could be part of the dimensions that the AI consider during training? I think it's still loading right here. You can you just put any guess that you have into the chat. So we have fearful, angry, disgusted, sad, happy, surprised, and what else? Is this bad? I think it's bad. I'm surprised that that's an emotional type. So under surprised, you have startled, confused, amazed, excited, and then under that you have shocked, dismayed, and all of that. So this emotion, if this is the full spectrum of human emotion, what would be your attempt to convert these emotions into numbers so that AIs can find patterns into them? Nobody's typing anything. Remember what we said? If we can find a way to convert them to numbers, the AI model will be able to find patterns within that and use that as a training information. But now, if we have this, that even as incomplete as it is, our approach in terms of our approach, what would be your best method of fearful? How would you teach an AI model that this is what fearful means, right? Or angry or happy? Eh? Or you want to speak instead of typing it? I'm allowing more people to be able to talk. If you like to speak, you can raise your hand.
I would like to speak.
Okay, please go ahead.
I think I've heard about something.
We can't hear you, or is it just me?
I thought about something of vector if convert almost into
Sorry, you're not clear. You can try again later. Your audio is not coming through clearly. I think Oluwatobi, do you want to speak? You have your hand up. Oluwatobi.
Okay, hello, can you hear me?
Very clear.
Hello, can you hear me?
Yes, very clear. Please go ahead. Can you?
Okay,
hello? I would
so
like to
in my own way, if I would do that, if I would probably want to I will use a computer vision model. Probably like my webcam, my facial reaction, and so probably when my teeth is open, what does it reflect? When I squeezing my face, what does it mean? So I think that's the way I could probably train
So
the
how
AI
would you
to
convert that to
understand that.
numbers? How would you convert that to?
I mean, that's how I can get.
Yeah, Oluwatobi Loba, how would you convert that to numbers? Remember, you are trying to train the AI model that when you open your teeth, it means something. How do you convert that to numbers?
I can't figure it. I can't figure that out right now.
Okay, no problem. That's a good try. That's a good try, actually. Yeah. Is there anyone else? Whose hands? I think someone else is raising. I was saying someone else is up just now. Maybe that's what this means now. Okay, Esther, you want to try? Chinemelum.
Oh, good evening, all.
Good evening.
Good evening, sir. Thank you for making out time to drill us again today. About the question you asked, I also want to thank the last speaker because he made a brilliant suggestion. But then, in addition, I am thinking now, I am thinking this from the place of an artist. Can I decide that a particular number or a particular series of numbers will mean a particular emotion? Is it possible that I can decide that 00027 should mean?
It is. It
Okay,
absolutely is.
okay, then that should work, because once I
Yeah.
decide it, I set it and I train my
Beautiful.
understanding.
It's surprising how simple the answer is. That it looks like that can be the answer, right?
Exactly. Yes, exactly.
Yeah. And that's how it is with AI. It is so simple that you will be looking at the answer and it will look like that cannot be the answer. Let me tell you what happens in all this ChatGPT is that every word in a dictionary has a number. Every word in every new word it encounters, because it's trained on the internet, right? All the data harvested from the internet. So if it finds a new word, it will assign a number to it. In word that it has not seen before, it will assign a number to it. It's as simple as that. So instead of your dictionary, I would say, apple means something. Apple, that, sorry, can you raise your hand if you would like to speak, please? Apple is, a fruit that does this. Is in, machine learning. Apple could be 22, and then now you train that model with that number, and then that to find pattern in terms of how those words are stringed together. That is the pattern in NLP. It's finding, okay, usually 24 comes after 42, and 42 comes after 192. and 192 is used together with this, and that is used alongside 892. That is a pattern that is finding, at the end of the day, right? So for each model, an anthropic would have its own structure, number to word mapping, differently from a Llama 2 or Llama 3, and differently from ChatGPT. So each model has its own one may not mean one, come for everybody, but it could mean come for model A, it could mean go for model B, it could mean, so the developer of the model will have an understanding of their own mapping, and that's what called word embedding. So as simple as that is, you are essentially arbitrarily assigning a number to a word and using that to train the model to find a pattern. We don't know what it defines, but we know that it defines something, And of course, we've always had recurrent neural network and all this older architecture around for some time, but they were not performant because they were missing something that came in 2017 in the transformer architecture, which is called the attention, the self-attention method architecture. That is essentially that's the biggest difference, because all of them, they are still, I don't want to mute any, I don't want to disable anybody from being able to speak. So you can, if you would like to speak, just signify. If you disrupt the class, I'll be left with no choice but to disable you from being able to speak. Okay. Ismaila, do you want to say something?
No, Cohort.
Yeah, please
I'm enjoying the
mute
class.
yourself. Yeah, you're welcome. You can mute if you're not trying to speak, so that other people are not they don't get distracted. Yeah. All right. So it's as simple as that. It's as simple as that. It looks like it can be ridiculously simple like that. What pattern is it possibly going to find in a number that I just assigned? But it is going to find that pattern. Now the pattern could be as I said, the words that are often used together. The words that are often for example, that is just one, actually. That's one method. Assigning number to words. Some people in their NLP implementation, they will assign words to character. It's not very good. That doesn't do well. It doesn't learn so much, because you have 26 characters in English, right? So what can it possibly learn? Versus millions of words that's possible to learn in a language, right? Or in corpus of the entire training data sets, right? So 26 versus millions of words is definitely not going to learn much with character based. But there's another one that is very common, which is token based. Token. A token, you can consider a token as a syllable, right? And essentially the way that works is, some words have patterns like, computation, information. They all have shown, and computation is the noun form of compute, right? So it can learn that, okay, all these words with Sean. It won't know that it means the noun form of verb tense. It is you that would know. But if you find the pattern that, okay, there's a relationship between these words and in the way they are used together, right? Again, we're using NLP here, but it works in the same in different modalities. When you go to images, now you start thinking in colors, in pixels, right? In audio, you start speaking in frequencies. Not word to number mapping again. So this is how all these numbers are often converted. All this data are often converted to numbers. No matter what you're starting with, you have to find a way to convert it to numbers, and then train the model so that the model finds pattern within it, in how it's used, in how it's essentially you're trying to confine compressed reality into numbers, right? when you have a lot of examples of how something has been used, how something has expressed itself, how something has been done, how something has happened, and then you represent that in some sort of data and you train that in the model, what you're attempting to do is to represent the facts of those, of the reality contained within the data into numbers that maps to those realities. That's essentially what you're trying to do. And that is the reason why it is now possible to convert back and forth. You can now ask an AI model to generate image, because it knows the different modalities that maps, between the data that it was trained on and then the weights. Now, if you part of cohort 1, we spent a lot of time talking about weights and biases. These numbers are essentially weights and biases on each neuron. So we spent a lot of time talking about those, right? So you can check the recordings for cohort 1 to have a better understanding of what are these weights and biases. But those numbers after training is essentially weights and biases, right? At the end of the day. So yeah, very good attempt at answering that question. All we just need to do is to identify the emotional pattern and then assign a number to them. The part that is challenging is the is the sensor. Firstly, to solve this kind of problem, you need to find, if you want to use the facial expression, that is where the first speaker actually tried to answer the problem from, right? That's where the first speaker tried to answer the problem from. If you want to solve this kind of problem, if you have a facial expression for all these emotional spectrum, right? So you can say this is 1, this is 1, this is 11, this is 12, 13, 14, 15, 16, this is 100 and 100, and assign those numbers, right? Essentially as labels. Now you would first of all do a classification model. If you have a facial expression, let's say you have 100,000 facial expression per spectrum, you can now train the first model. You would train the first model that we understand those facial expression or human posture or gesture, and all of those. Of course, the data needs to be a whole lot. By the time you now pass image stream, camera stream to that classification model, you will get the current emotional state of a what's it called? Of what you're trying to, the problem statement you're working on, right? And now how you want to essentially represent that is that at the end of the day, each of these will be reduced to a number. Each of these will have to be reduced to a number where you will understand that, okay, 1 means fearful, 2 means angry, 3 means disgusted, this one is sad, and all of that. So that is how that kind of problem will be attempted. And there are a bunch of models out there that already have, off-the-shelf models, foundational models that you can use to solve this kind of problems. It's just not as sophisticated enough as human brain. Human brain can easily understand someone that is happy, someone that is sad, someone that is angry, someone that is, going through a lot. You don't need to talk. Once you see the expression, or the human brain will pick it up and can process it, right? So moving on real quick. So AI relies on predefined algorithms and lacks the same level of contextual understanding and ethical reasoning. Yeah, we spent a lot of time, discussing this. If the AI algorithm, again, what the major difference between the transformer architecture and the other neural network architecture, there are much more differences, right? Especially by the time you are even trying to break it down into modality. There are AI models now that you can send an image to them, they will describe what is happening in that image for you, right? Some of them, let's see. You all can still see my screen, right? So some of them look like these. If you go to Hugging Face, yeah, let me just go to Hugging Face of CEO. If you come here, you'll see a lot of those foundational models. If you go to Hugging Face, Hugging, sorry, G. I missed a G here. If you go to Hugging Face .co and you go to models, and you go to models, and you go to image to text. So let's see, computer vision, right? This image to text. These models can describe what is happening in an image. For example, this was developed by Salesforce. This was developed by Salesforce, and you can see the architecture right here. So some of the attention architecture is really what makes the transformer model shine more than the previous neural network that we have, right? So they have attention architecture across different things, right? Self-attention, cross-attention, right? So as long as this model is is concerned, once it gets the data, it will follow through this architecture to process the data and then to be able to learn whatever it needs to learn. It cannot veer off it. It cannot veer off it, So if you pass in this kind of image, to the model, and then you ask a question. If you ask a question, so image captioning, right? So if you say image captioning as part of the question, or you say, what is the dog wearing? Right? The model will be able to come with an answer to say the dog is wearing a pair of glasses. That's essentially what they described here, right? The man in blue. So this is the first use case of the model, right? Image text retrieval. So the first one is attempting to describe what is inside the image. The second example is captioning the image, and then the third one is trying to ask a question about the image. What is the dog wearing? You put in an image, you put in the question, and then it gives you the answer. So it follows that algorithm in total and cannot decide to say that, okay, in this certain scenario or in this certain situation, I'm going to do something else. No, it cannot do that. Right? So what you saw there in this example is just this is how all transformer architectures are. Sometimes there are different attention methods. They will just change the attention mechanism, or they will change the number of layers, right? Some of them are decoder only, some of them are encoder only, some of them are decoder encoder only architecture. We will not go into again. Our goal in cohort 2 is not to be very academic. Last cohort we spent a lot of time on the what is happening inside the architecture, what is happening here and that. But here we just want to focus on the core message or the core opportunity that exists with that particular architecture, right? So we don't want to go the academic route and explain how the data is transformed and then how it does one thing and the other, right? In the second cohort, we want to focus on application, making sure that you can build your own model, making sure that you can deploy your own AI model, making sure that you can create use cases around your own AI model. But this is essentially how it works, right? Image caption, Iman. I wish I could stop this. It moves too fast. So if you use image captioning, if you use question, it will use this layer, But if you use, okay, someone is raising their hand. Okay, I'm coming back. If you use image retrieval, it will. If you use image retrieval, you'll get your answer here, right? A man and a dog are reading a book together, right? And that's actually what is happening in this image. So that's how the model works. So if you want to run it, it's just, it's pretty straightforward to run it. You just copy this code. That's it. Pass your image into, where is it? Process raw image. This is the raw image. Process the raw image, and then you have your, output right here. Right. So that's how to use the image. Of course, that's to load. You have to reference the name of the model you're using that is hosted right here, and all the rest is true. Point I'm trying to make is that it is the specific algorithm. If I go to the ChatGPT 2 architecture, it has its own specific way it processes the data. If we go to the audio model, it has its own specific algorithm it uses to process the data to extract information from the data, and it cannot veer off that. Someone is raising their hand. Let me quickly go back to that place. Who is raising their hand? Babatunde. Babatunde, please go on. Oh, okay. I've not given you access. Sorry. Else haven't I given access? Sorry, Babatunde, you can speak now.
So sorry, sir. I actually wanted to talk, but I didn't want to tell you that I couldn't talk. Sorry. So sir,
Oh, no problem.
I wanted to ask, which websites were you using to like analyze that? Like, which websites were you using previously for what you just did now?
Huggingface.co. I'll put it in the chat. Oh, okay. I'm just seeing your response. I'll put it in the chat.
Yeah. Is that like a website for analyzing AIs or what? I don't understand. So confused.
Okay. The way GitHub is, right?
Yeah.
For hosting codes, open source codes, and all of that. So now we have a way. So now we have a way of people collaborating on models, just like GitHub, but now AI models. So that's what the site
Okay,
is.
sir.
Yeah.
Okay, sir.
So people share their different architecture. Oh, me, I changed this multi-head attention. I changed it to self-attention. There are nuances in terms of what those things mean, right? But people just mess around with different architecture, and then they share their performance, right? And also they share. Just think of GitHub, but specifically for AI model, right? So if I want to deploy this model now, I can deploy this model from Hugging Face, and then I can start using it. So that most people when they are trying to post picture on Instagram could implement this feature to now say that, okay, instead of you racking your head around caption, they will just use this model to do automatic caption for you. That's possible. Now with this model, it will look into the picture and then give you the text of what's happening in the picture, something like that.
Thank you so much, sir.
You're welcome. Someone else's hand is up. You can lower your hand, Babatunde. I think did he just speak now, Babatunde? Okay, all right. Do we have anyone else? Okay, cool. All right. So let's move on. So yeah, different models. What God says is that different model has a different architecture, and they follow that in total, right? Unlike humans, humans can analyze complex situations, consider multiple perspectives, and make ethical judgments based on values and principles, right? So people have been confusing AIs lately. They will say between Kylie Jenner is a trans person, right? Converted to gender, and of course there's a political spectrum that believes that people should not be, allowed to change their gender. There are only two genders. There's another political spectrum, they call them the left, right? That believe that people can be whatever they want to be. If they want to be goats, call them goats. If they want to do anything, let them do it, right? So someone out tested ChatGPT, say, hey, between refusing to call Kylie Jenner, not using Kylie Jenner pronoun and letting the whole world die, which one would you do? that is a way of confusing. Of course, I mean there are ways to get around all these things. So it's called RLHF, reinforcement learning by human feedback. So they've actually, what they've done there is to reflect human values through RLHF, reinforcement learning by human feedback. but they might have overcompensated for that to not offend the trans people. And now the ChatGPT saying that let the whole world die, but don't call Kylie Jenner a wrong pronoun. You know, so the RLHF is just a way of introducing, of controlling the AI. Let me say that, right? It's a way of controlling the AI or aligning the AI. Yeah, that's the right word. If you train an AI model, it will learn its own weight from the weight and biases. It will learn what is represented in reality by itself. But now, if that what it has learned is not good enough, you can now align it with RLHF to say that okay, we don't like to do certain things like this, even though it's the truth. You can align the AI. Yeah. So point is that we have to do that. We have to do that because it's an AI. We have to invent that method because it's an AI. But in human judgment, you know that okay, you go to jail if you, in some countries, it's jailable offense to say that okay, someone says that they should be they, and then you're calling them he because they look like a man. It's a serious offense, right? But you, as a human being, you can easily use your judgment for that. But AI would not, right? And it's essentially why we had to, find a hack around that particular problem, right? But point is, humans are able to, judge things fundamentally and then take a stand. So the next one is AI can be trained. AI can be trained to generate creative outputs. AI can be trained to generate creative output. It lacks the same level of adaptability and creative thinking exhibited by humans. If you go to Midjourney right now, someone is not muted. Do you want to speak? Hello, who is there? Femi?
Hello?
Femi, are you trying to say something?
Can you hear me?
Yes, I can hear you. What's your question?
Okay,
I didn't see your hands up though.
okay,
I can't hear you.
hello.
I can hear you,
Can you hear
unfortunately.
me?
Yeah, it's muffled. It's muffled.
Okay, sorry, I lost it. Okay now.
Go ahead with your question. I think I can make some sense of it.
Okay. No, I didn't want to. The last section we had, I was finding it difficult to actually pick my data.
Sorry, you're not loud enough.
Okay, can
Sorry,
you
you're
hear
not
me?
loud enough. Can you use the QA to put in your question as
Okay,
text, please, so that we don't waste time. Yeah, it's not loud enough. You can mute now. Thank you. All right. So even though AI can they can try and pretend like they are creative, they are really not. They are not. We spent some time to discuss AI creativity here, and I would share my other screen here in a moment. Okay, so let me share my screen here. AI is pretending like it's creative. It's really not creative. It is mathematics that it is doing. And it does the math so well that it makes us believe that it is creative. Okay. So right here, this is an example of, we talked about dimensions, right, earlier. Dimension is essentially all the inputs, all the ways that an AI model can receive those number inputs. Those are the dimensions, right? Think of them as that. So if you are training your AI model with two inputs, it will have 2 dimensions, right? If the model is, why is this thing not going? If the model is, excuse me. Okay, sorry. What is going on? All right. Okay. All right. So if the model is, if it considers three different parameters, that the model will consider 3 dimensions. So here's an example of a simple problem where there's an x and y dimension, right? So consider a scenario where you have just 2 dimensions, x and y, right? If this is the if this is a function that maps to that scenario, you have your y-axis here, and then there's your x-axis here, right? Now, if y is equals to 1, let's just, for the sake of simplicity, let's assume it's a linear function. Real life functions are complex than that, are much more complex than that, right? Real life functions. Everything is a function. Everything is a function. What an AI is doing is learning the function that describes that reality. AI is essentially learning the function that describes the reality within the data. That's all that it's doing, So real life function can be anything from hyperbolic to anything else, right? There's a function for every phenomenon in reality, essentially, right? That's what I'm trying to say. And because we don't know the function, AI learns that function, and then it can use it to now predict, for us. That's essentially what is happening right there. So this is just a two-dimensional problem. It's very simple. It's very, so if you're, you can easily just map what y means when x is one value, what x mean when y is particular value. It's very easy, right? It's very easy. So if x is your input, you know what your y value is. There's literally nothing in reality that's like this. You can take that from me. No meaningful problem set has this kind of function, right? So let's, but by the time we complicate it a little bit to make it a 3-dimensional function, it will start having more reality use case, right? So there are some functions in reality that are in 3 dimension, right? You have your 3-dimensional space here. This is your x, this is your y, and this is your z, right? And then the curve or the line could be, let's use line as an example here, to just simplify it. So for each, there is value for x, there's value for y, and then there's value for z, there's value for y, and then there's value for x as well, right? From any point. That is what is happening. So now, when you train your ChatGPT, or you train your Midjourney, you train these things don't have 3 dimensions. They have thousands of dimensions. We cannot think outside 4 dimension as humans, which is also a limitation. But mathematically speaking, there can be n number of dimensions, and it will still be mathematically accurate. For example, that third dimension, this is height, this is weight, this is length, right? It's easy to, because we live in third dimension. From fourth dimension, you'll be like, okay, where is the fourth dimension? Where's the fifth? Where's the sixth? So it is it used to be a course. They call it course of hyperdimensionality before, in the past, when when AI was still emerging. But now it's a blessing, because it is the hyperdimensionality of AI models, the fact that they can have 100 dimensions, that allows them to be able to store more information about the fundamental patterns within the training data. If it is just 3, it's too small. Like how much can they store? Right? So it is the same course of hyperdimensionality that I used to say in the early 2000s that is now the blessing of the transformer model today. So let's still because we cannot think outside third dimension, because we cannot think outside third dimension, we will assume that ChatGPT has 3 dimensions, right? Let's still go ahead with that assumption, right? So you have a third, a 3-dimensional plane right here. After training, what happens is that ideas that are similar, that are used together, that are contextually meaning the same thing, are clustered around the same region. That's what happens after the training. Again, remember that we are simplifying it by making it 3 dimension. It is typically more than 3 dimension in reality, right? So if this idea here represents cars, this could represent, animals. This could represent, this could represent bikes, this could represent houses, different types of houses and architectures and all of that, duplexes, bungalows, and all that. So it collocates them. And then from the training, it knows, it has a pattern of how, those ideas are interconnected. That's essentially what happens after you've trained your model. Again, we're using 3 dimensions to simplify, and then we are only narrowing down to text domain. But you can expand this to pixels. You can expand this to frequencies. For audio, and pixels for images as well. It's the same concept at the end of the day, right? So there is a particular mathematical function when it's calculating attention. How your different there are different attention mechanisms, right, in transformer model, but there is one thing that they all do is that they compare similarities of ideas, to know that, okay, what is it in this sentence or in this word I should focus on, and that I should spend the most amount of energy, which it means weight on, right? So how it knows that is that it does a cosine, they call it cosine similarity function, right? So when you're saying that, okay, I'm going to be roasting rotisserie chicken in my oven. So it will be able to connect something about oven, roasting, and maybe chicken, in some sort of ways. That is the attention stuff. And what the attention mechanism uses is essentially cosine similarity. So if you want to find how far apart are ideas of cars and animals apart? How far apart are they, right? All you have to do is to draw a particular line from the idea that represents this one, and then let's say this is animals, right? Or let's just use this so that it will be easy. And then this. And then the difference of the angle is the cosine of the angle between the 2 ideas is what tells the AI these ideas are too far apart. They're not similar at all. Again, you see how the AI is essentially the model is using mathematical concepts to just turn ideas, reality, into numbers, right? And then it knows that, okay, what I need to pay attention to most here is the oven and the roast. You know, that's the verb tense of what is happening in this sentence, right? So if what is cosine of 90 degrees? Are we still together like this? Together? What is cosine of 0? Let's do it together. I'm still sharing my screen. You all can see my screen, right? Cosine of 0, right? Can you see? Cosine of 0 is 1. What is cosine of 90? Cosine of, it should be in degrees, not radians. In degrees, 90 degrees. You should have 0, right? So the far apart those ideas are, the more the cosine angle punishes the fact that they are far apart. And then the ones that are closer, it will reward it by essentially paying more attention to that. So that it is the same plane. If again, in our own case, we are narrowing down to 3-dimensional planes, but in reality, it is way more than 3 dimensions. We are narrowed down to 3-dimensional planes, but in reality, it is way more than 3 dimensions, right? And then we are using text as a way to just explain this, but in reality, it applies to any other modalities of data, voice, images, and text. So that's how it, knows that ideas are similar. So let's now, come to how what we're trying to answer here is creativity of AI, because they it's as if they are expressive. It's as if they can compose things, they can, so we are trying to explain it mathematically how they are able to do that. Right? So now we've established that every word, again, still using text modality, right? Every word has a number mapping, NLP, right? Or token mapping, number mapping for the token, or word mapping for the token, right? So for a transform model, when you type into ChatGPT, what happens is that, okay, I think I have a window here. What happens is that the words are converted to tokens like this. So you can see, let me copy this. OpenAI large language model and token, right? Okay, right. So I will change it to token IDs. So OpenAI's, the guy assigned this to open. Okay, let me convert it back to text. Okay, so open, can you see? OpenAI is one word, but this guy broke it apart because he knows what open is. He knows what AI is. And he knows what anything with apostrophe S is. This is a token-based model of solving this problem. If it is one word, OpenAI, this entire word would have been one token. But can you see, open is one token, AI is one token, and apostrophe S is another token. And then it assigns a number to each of them. Can you see? This is open, this is AI, this is apostrophe S. This 13 is the full stop. If I keep, right? So now, so period, let's say period. Can you see 13 again? So period is the full stop. The word period is this number. Again, full stop is 13. Tokens is this, right? So this is a token-based approach where the number mappings are with the number, with a word, are presented in this way. So now, for you to be able to, if you say that, okay, give me a text, write a text that sounds like writing of Shakespeare in the tone of something else. It knows the dimensional representation of Shakespeare, right? Excuse me. I hope I've not lost everybody in this class. The way everywhere is silent. Okay. Yeah. So now all that is happening is that all those vectors, 2x plus y, and z, and all of those things, to do multiplication of vectors, to do addition of vectors, if these are vectors, right? 2x, if you want to do addition of vectors, the final vector here would be minus 2x plus 4y equals to 3, equals to 5 rather, right? If you do addition, if you do multiplication, you'll be getting minus 8x plus 3, but you get the idea. So what is happening is that when everything, the information is stored in some sort of vector forms within the matrices within the model, and the model can do mathematical operations on those vectors to make it look like as though there's creativity involved. So if the AI model understands what a chair is, and it understands what avocado is, and I ask it, give me a picture of an avocado that looks like a chair, right? It will be able to do vector manipulation, essentially just like the mathematics that of course, over hyper dimensions, and then be able to represent that idea to you as though it's creative. So that is how AI creativity works in a nutshell. That's a long-winded answer to how does AI appear to be creative. Is there any question on that? Do we all understand that?
Although it's complex, but just
Yeah, it may be complex, it's just the models representing ideas in different planes, such that by the time you are trying to infer, it goes to those places and then run matrix multiplication to give you your answer. Let me give you another example. The entire ChatGPT 3.5, the model weight is like about 120 gigabytes. The entire model weight that has the numbers in it. But the ChatGPT 3.5 was trained on the entire information on the World Wide Web. How can all the information on the World Wide Web just be 100 gig? It should be like thousands of terabytes or thousands of petabytes, right? Isn't it? A Google that has the same that was went through the same process of collecting all the information on the web has thousands of millions, billions of petabytes of data that they've scraped. But the difference in the weight or in the size of amount of data they have to deal with is because what Google will do is that Google will carry the data, go to your website, your blog that you've written, they will carry it, go read through it, and store it in a physical hard drive, SSD, right? And then when you ask question, what is this? They say, okay, based on the websites that we have crawled, this one matches. They will serve it to you, right? But the size of their data center, it is essentially a linear graph of this number of websites and the number of data that they have scraped. But how come a ChatGPT model is just like 100 and something gig that you can save on your computer. If you have space, you can save it on you can literally save it on your computer. The entire information of the world. That is what that represents is that all the similar information contained in Google with billions of petabytes has been compressed to planar information in dimensions within ChatGPT 3.5. So it is alike. It's like similar things, but represented in two different ways. For Google, all they will do when you need that information is just to go to the place where they store it in their SSD, rank it using their own algorithm. They have a ranking algorithm and they serve it to you. What a ChatGPT will do instead is that when you ask a question, for example, if I come here to say that what is photosynthesis, if I come here and say what is photosynthesis, I think this is it. This is the right. What is photosynthesis? This is 3 words but 6 tokens, right? Let me put question mark to 7 tokens, right? So let me put it in text. Can you see? Photos and then Y and then int. Well, this is how he broke it down into tokens, right? So what is a token? Is a token, and then photosynthesis is about. It could be me that's not getting the spelling of photosynthesis right, but yeah, this is it. This is it. What happens is that this number is what ChatGPT says. This number is inserted into the model, that the ChatGPT model at the back end. This array of number exactly in this sequence, right? What the model is trying to answer is what is photosynthesis, right? So this number will be inserted into the model, and then the model will know that, okay, what you're trying to know is what is photosynthesis, and then the first output of the model will be this number. So it will first of all print out 3923. This is a print it out in this exact format, and then it will start, explaining photosynthesis. So you now see the next number 522. 200. Let me see if I can even demonstrate that. Do I have a ChatGPT open close by here? Okay. So let's see. Okay, you know what? Let me not waste time there. But that is what happens. So what the ChatGPT guys will do is to now remove this one, because this is the question you asked. You don't want to see your question again in the answer. They will now use, normal traditional programming method to remove this, right? That is what they do. Again, we don't want to get into the nitty-gritty of, okay, is it a decoder only transformer, an encoder only transformer, an encoder decoder only? But a ChatGPT is if you want to further study about what is going on there, a ChatGPT is called a decoder only model, right? So it will, first of all, this is the input. This is the input. Now the output will look like this. Let me use my text. So the output will look like this, something like this. And this could be photosynthesis is the process by which blah, 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 blah. So ChatGPT will use the traditional programming method to now remove this part, so that all you see is this one. And then this is it trying to explain what a photosynthesis is. Right? So each token will have its own word. And this is how it appears as though this guy is intelligent, because it has compressed reality based on the amount of text it has trained on into numbers, convert that into some patterns within the hyperdimensional plane. And then when it needs to, during inference time, is running, a matrix multiplication operation to then know what should come out as prediction. These are the predicted numbers of the right word. And then by the time you know it, it will form a full correct sentence that appears that it is intelligent. Sorcery, isn't it? Isn't that sorcery?
Yeah, it is. I like to ask a
Femi,
question. I don't know if you can hear me.
Yes, thank you
you have a
so
question,
much.
Femi. Please go ahead.
Yes, I do. So I don't know if I missed this part of the class, but I would just like to know if this is also the same way it runs for other other formats, input formats such as images, sounds, and the likes.
Okay. So the input output is different for those different for other modalities. For sound, what it does is that, for example, what I'm saying right now, we sample it. Sampling is essentially extracting the token. No, token frequency is already a number, right? 200 hertz, 500 hertz. Frequency is already a number, but we want to know the frequency at every microsecond, so that by the time if we're getting the frequency every second, we've lost a whole lot of information as part of what is contained within my voice. So what it tries to do is to extract that number from so as high as 48,000 times per second. That number is defined by the developer of the model during development, but 40,000 is a very popular number that is used. 40,000 is a very popular number that is used by model developers. So every second, it will extract 40,000 frequencies at each, that's not even microsecond, right? But you get the idea, So it will extract that. That's the number that it uses to then, that it train on, such that during inference time, those are the numbers that it's predicting. So it's predicting the frequency that it should be. By the time you put those frequencies together and you play it, it will form actual words. It could be music, it could be, some text to speech, it could be whatever. So for images, don't worry, we'll still get there. It's still, we should be running up soon. In another 30 minutes or less, right? But we'll get there. In images, what is essentially happening is that those pixels, right? Let me share my screen again here. 1 second. Let me share this. So for images essentially, think of image as a grid. Think of image as a grid of data. It's taking time. So if you have an image, of course, there's no image that is like 10 by 10 matrix, So let's say this is an image. Let's break it into some cells as much as we can get, right? Right. So this is about 1, 2, 3, 4, 5 by 4 image, 5 by 4 pixel. So the total pixel on this image is 20, right? There's 4 on each row. 4, 8, 12, 16, 20, right? 4, this is a 5 by 4. This is a 5 by 4 image. Okay, so this is a 5 by 4 image, right? So each tiny box is a pixel. Each tiny box is a pixel. So now each pixel has its own. If it is a black and white, it's easy. If the picture is black and white, it's very, very easy. You can say white is 1, black is 0. It's as simple as that. It's as simple as that. If it's black and white. But if it is colored image, you will now have to, convert that color to numbers. How you will do that is that you will find the what makes up color images. Do you guys know? Let me see if anybody has an answer in the. You can unmute and speak. What are the 3 colors that makes up color? Colored images.
RGB.
RGB. Beautiful. So you have R, you have G, and then you have B. Each pixel, we have RGB. This thing is so accurate that even if you have your crayon or watercolor and you mix these colors in this particular way, you can create more complex, highly sophisticated colors. So if you have red of 204, you mix it with green of 52 and then red of 108, you will have a particular color that it maps to. So the program will fetch all per pixel. It will fetch how many red is in this pixel, how many green is in this pixel, how many blue is in this pixel. Right? I think there's a program that can help us do that. Let me show you. In this deck, you will have access to that. In this deck, you will see that if you come here to images and then come to rapid tables and then go to the website, right? So red, let's say red is 204. This is what we did just now, 204. Green is 52. We want to see the color that it will create. Green is 52, and then blue is 108. We've just created purple, right? So purple has this amount of red, this amount of green, and this amount of this amount of blue. I think it's really not purple, but somewhere in the middle like that. So that is how that it will be done for each pixels. The amount of red, the amount of blue, the amount of green per pixel will be collected. So if you have an image that is 3 megapixel, your cameras are in megapixels, right? So what is your camera is doing is painting those pictures. The amount of the amount of colors that your camera can paint is defined in those megapixels, right? So if you have a picture, of your vacation image in that particular form that is like, it has 3 million pixels, so that would be like around the 3 MB size, right? So you have 3 million pixels. So how many numbers would it be? So let's say, okay, let's even say 124 by 124, a square image, right? And then you have 3 colors per pixel. So you would have the total number of numbers that the AI model will process, would be 124 by 1 multiplied by 124 multiplied by 3. And that's essentially what this guy is discussing here. So by the time what the AI model is predicting to create the picture of that Mona Lisa, when you type in your Midjourney or in your DALL-E, is predicting amount of color in each pixel to paint a particular image. So a ChatGPT is predicting the text mapping for the word that should follow next. An image model, a text to image, is predicting the amount of red, amount of green, amount of blue that should be in a pixel for a particular image to create what you're asking for. An audio model is predicting the frequency number that should be in a sampled space, a sampled point. So you can see, at the end of the day, it's simply just a predicting machine. What they are just predicting is different, right? But it's easy to predict numbers because numbers are, that's how it works. Everything is still numbers. So whether it's frequency is a number, whether it's color is a number, whether it is text is a number. So it's predicting those numbers and then combining those numbers together to recreate the kind of thing that you want to see. Does that make sense? Or is there any further question?
It makes sense on my end. Thank you.
Welcome. All right, let's proceed and quickly round up. Okay, it's still recording. So you see, this class is so important that once you grab this, you can venture into any AI development, whatever AI type it is, and you will figure it out. Our last class 3, we did a regression model where we were predicting house prices. It's essentially a simple regression model that considers some data points and then use it to predict house prices. So by the time when you're trying to explain what is going on within the AI model, you'll be able to even, some of these concepts will help you to be able to explain it, you know. So once you grab these, you would have the fundamental to build any AI model at all that you would like to build over time. So yeah, let's proceed real quick, and we are pressed for time. So yes, so we've explained this. We've explained how AI is creative. Of course, human creativity is easy. Just, you know, some people, they will smoke shisha or smoke something, you know, but you know, you just need to be calm-headed, you know, and think abstractly and combine ideas together, and then you are creative. You know, people that sing, people that draw, you know, that's what they do. They combine ideas, different ideas together, and then create a new novel ideas. And that is actually, if you notice, that's what actually that AI models do. Right? This is actually very interesting. I'm just thinking about it right now. You know, here, how AI does is to combine ideas stored into vector form across different planes. But here, humans, what we do is to combine ideas too, at the end of the day, to show creativity. We combine idea to create a new novel thing. But the AI does it mathematically. We do it in a, you know, by thinking, obviously, right? So here, the training data typically includes audio, video, images, and text. You know, the other types of data that you would like to inject, you have to engineer it to convert it to numbers, right? But this audio, we've explained how to convert it to numbers. Video, of course, is an array of images. Images, we've talked about how you convert it to numbers. Text, we've talked about how to convert it to numbers, right? But here, instead of, you know, audio, images, and text and all of that, the training comes from the 5 senses, 5 human senses, and the metadata on social construct or social context, body language, and other immaterial art form. Right? Again, the way we talked about body language, you know, earlier. Or when a baby is attracted to light, you know, the light that is dancing, and then the baby wants to touch it. Oh, don't worry, just let the baby touch it once. The baby will learn, you know, by the sense of touch, that it is not to be played with. That's just how we learn, right? But for AI, just convert it to numbers, the AI finds patterns, and then to be able to predict whatever it needs to predict during inference time. So that's how it works. I'll skip this. Everything I've explained is essentially all the numerical manipulation that is happening within an AI, right? While I was sharing my freeform board. Or it's just numerical manipulation. It's just manipulating. When it wants to show creativity, it's manipulation that is happening. It's manipulating those ideas, those vectors, right? That's what is happening. And then, of course, image processing, I've touched on this. You know, so for black and white, you can say 0 and 255. Or 0 and 1, depending on what you want, right? But 255 is actually a RGB value for white. 0 is for black, right? So, and then that's how we convert, you know, that's how we process images. For text, I've already explained it as well. You know, we just have a token. Either we have token, character, or word. Or there's some people that have even done bytes, you know, byte of text to numbers. But so far, we've seen that token method has really been the most performant in terms of the structure and architecture. So yeah, we've talked about all of these as well. You know, this is how this is how it processes the text and then finds patterns within the text, right? For audio as well, we've touched on this. This is how it converts frequency, you know, to numbers, and then predicts the actual frequency when it needs to generate the voice. So you can see that our reality can be converted to numbers in some way, shape, or form, and this is what AI has found out. You know, when you're speaking to ChatGPT in voice mode, your voice is converted to numbers. The frequency in your voice is converted to numbers, fed into the model, you know, and then fed into to get the text. When the text is now fed into the AI, the textual LLM, and then that is also predicts some numbers, and then that is fed into some text to speech to convert it back to voice so that you can hear the ChatGPT. So it's a bunch of, you know, numerical computation that's happening. And because of the size of the competition that is going on is really why why it is often important to use a GPU. CPU cannot process it because multiple parallel computations needs to happen to know the number to print for text, or to know the number for frequency, or to know the number for image. There's a lot of numerical computation that needs to happen, and that is essentially why GPU is necessary for AI computation and training. But at the end of the day, that is essentially the background of what is happening within an AI system. It's not more than that. Okay, let's close with this. Excuse me, let me drink some water. Any question before I continue? Any question? Is there any question here? Okay, RGB0. Okay, fantastic, sir. Let me speak. Okay. Emmanuel, no problem. Is it possible for us to get your details? Okay. Sure, I'm on Telegram. You can message me on Telegram or on WhatsApp. My detail is right there. What's my name on Telegram though? Let me see. Let me see. What is my ID on Telegram? Surprisingly, I can't find my. Well, I sent the last couple of messages on Telegram, so you can chat me up on Telegram or on WhatsApp. I think I'm Reels the Legend on WhatsApp. I just don't know my Telegram username. Yeah. So please, can we get a slide? So you get a slide at the end of the class. Esther, do not worry. Hello, please. I've been raising my hand. So sorry, Emmanuel. Hi, Emmanuel. Emmanuel. I believe that it's your question. You've asked your question right here in the chat as well. Yeah.
Yeah.
All right. I'm believing that there's no further question. Okay, you've already asked it. Okay, awesome. So let's close with this point. Let's close with this point. So here is a game of charade. In this game of charade, this woman here would have to put something on her head, and it could be a piece of paper, or a piece of cardboard. But there's a game of charade on Play Store now that you can install on your phone. So if you install it on your phone, it will show a random number. It will show a random number. A random text. And these people here, what they will have to predict, they will have to say things to you that will help you predict what is here without telling you what is here. So if what is here is if what is here is fun, so these people here can say it rotates, it blows breeze, it's it uses electricity, and then this woman here, we guess that, oh, what you're talking about is fun, So right here, these are the independent variables or data that you are using to train the model. They say things, they say anything, but what is here? This is the model right here, and this is the target variable that we're trying to predict. These are the features. This is the model, and this is the target outcome that we're trying to predict. That's how it works. So if I ask you, what are the features? What are the things? If what is here is Ronaldo, what can these people say that will help this woman know that what is here is Ronaldo? You can unmute and say and speak. What will those people in front say without saying Ronaldo that will help this woman say no, that what is here on her head is Ronaldo?
Plays in Saudi Arabia.
Plays in Saudi Arabia. That's a good point. But guess what? there are hundreds of people that play in Saudi Arabia, but it will nudge her in the right direction, but we will not give her the answer. We need more.
Tains the Portuguese team or football team.
Okay, and Portuguese national team. Okay, well, maybe with these two, I think that woman should be able to guess. But that's a very fantastic idea there, right? Just those two things can nudge that woman in the right direction to, help her know that, okay, what is right there is Ronaldo. So that is how it works. That is how it works simply, right? You compress information together, process it to be able to predict the target outcome at the end of the day, right? And during the actual second class, not the rerun, the actual one, someone said there's one variable that these people can say that will, I can't recall what the person said. I think the person said, okay, is shares goats title, or battles with the title of the goats with an Argentine player or something like that. I think it's related to that. That single sentence, the person here battles with the title, with a goat title with an Argentine football player. It's with that single stuff will help this one. If this one knows football, she'll be able to predict just with that alone that what she's here is Ronaldo. I think that's what that person said. So that shows us that different information has different predictive power. No two information are born equal, So different information would have different, predictive power of the target outcome we're trying to predict. And this is why you need to work with the subject matter experts in terms of what the AI domain that you'll be working in, right? Our goal again of this second cohort is to make sure that after this cohort, you can take an AI model to production. That is our goal. So, but in doing that, you need to understand the context of, why some of these data have predictive power and what is the predictive power of each of them, right? So that is a very important information as well. So this essentially says information is everywhere. What is an information system? You can predict if person will die tomorrow. If you have access to the right information, you will be able to predict it fine. You will be able to predict correctly if someone will have cancer next 10 years. If you have access to the right information, information like what is happening in the cellular level of that person. We can't capture that information today, but that information exists. It's happening anyway. Your cellular your cells are dilating, they are receiving oxygen from the blood, they are receiving water, they are receiving glucose, whether they are receiving all those things at the right time or not, some of those cells are dying. If you can collect all those data of what is going on, you'll be able to correctly predict what is going to happen to someone, accurately. So our problem with some of the things that we cannot solve in the world today, we know how to solve them. Some of the problem is based on the limitation of, number one, collecting the data, or number two, processing the size of the data, right? So now we can collect information at organ level in the human body. When you place a stethoscope on the heart, you are collecting information. You are collecting data at the organ level, right? To listen to the heartbeat. When you put sphygmomanometer, what do they call it? To get a blood pressure, you are collecting information at the organ level, but there are information at the tissue level. We can do that. We have limitations in terms of how we can collect the data. There is information at the cellular level. We can collect that. There is information at the atomic level of every person. So, but that will be some insane amount of data that we cannot process. It will be more than the amount of data that we've even ever created in the world, if we want to get to that level. But there are predictive patterns within those data that will tell us, that can actually be useful, predict diseases, predict illnesses, solve some of the world's, problem that we cannot solve today. Our limitation is, number one, in collecting the size of data, and then number two, in processing that much data with meaningful time frame. You don't want to be predicting that person you will have cancer next 10 years, but your prediction is coming 30 years after. Is useless. You want to be able to predict it in time, after processing that size of data. So what you would see happen, the trend you will see happen, is that our capability to process more data will increase. We can process data in thousands of petabytes already, but we can collect thousands of petabytes in a single moment. It takes years to collect that size of data. So the trend that you'll be seeing is that there will be improvement in our ability to collect more data, and then improvement in storage of the data, and then improvement in the processing of those data to create more sophisticated AI. We've not seen anything. All these old ChatGPT that you are seeing, generating images, they are like scratch on the surface of what is going to happen in the next 20 years. But the same foundation of what we have defined is still what is going to be happening. The only thing that will be changing is the size of the data, the speed at which you are able to collect the data, and then the speed at which you are able to process the data, right? Where you are seated right now, there's a bunch of data about you, the GPS location of where you are, the your DNA information, that's some data, important data, your your typical frequency. Different people sound differently. That information is contained within the frequency of their voice, right? Your height and there is a bunch of information around you. We're not collecting those information because we don't know how to store them or collect them efficiently. If we collect enough information, we can predict anything. And that's where God, is actually, more than us, because he sees all the data across the world, right? So he doesn't know he doesn't even need to predict. He already sees where everything is going, right? So our limitation as human is our ability to collect, process, and store data, right? And this is where, okay, I think we have one more point, a couple more points. Yeah, so essentially the AI the world is an information system, right? Our limitation is just in the ability to collect it, process it, and create models on it. Yeah. You have access to this deck, and then you can just read through the rest. But I think the main point of the class 2 has been expressed, has been passed on. With this information, you should have the foundational understanding of what makes an AI model work. Why do they work? How do they work? You have that foundational understanding, and you should be able to carry on with the next subsequent classes without any problem, with the understanding that you have today. Any question before we end the class? Any question? Question? Questions. Don't worry, you'll have access to this recording. You can watch it as many times as possible till it sticks. We've shared a lot of advanced ideas here. You may not get it the first time. Watch it as many times as possible till it sticks. Once you get this, you can build any AI model. The rest will be technical. You understand how it works. The rest would be technical, right? And I hope it's worth your time. We about 7 people have left the class, but I'm sure they're trying to catch up with a recording. If there is no question, let me wait a couple more minutes. Any question? There are no stupid questions, so you can ask any question that you want to ask. No stupid questions? All right. Right. Let me ask questions if you're not going to ask questions. Should I ask questions? if you want to predict natural disaster, if what the woman is carrying on her head is natural disaster, what would be the what would be the features or the highly predictive data that you would collect to be able to predict natural disaster? You can unmute and speak. Don't worry. Feel free to unmute and speak. I think I've not allowed some people. Hello? Are we there?
We're here. It's just taking a few minutes to think about it.
Yeah, don't worry. Take your time. If you're trying to predict natural disaster, hurricane, typhoon, tsunami, what should those people be saying that will give you, oh, there will be hurricane tomorrow or there will be tsunami tomorrow? What are the training data that you go after?
So I'm guessing weather forecasts.
Very beautiful. Weather forecast. Yeah. Because sometimes temperature drop, sudden drop in temperature can predict something that is likely to happen in the next few hours or next few days. Or sudden rise in temperature could predict something that's already, because all this phenomenon that is happening in reality are changing some things that we measure, right? So weather forecast is a valid point, right? More examples. More examples. How about satellite imagery? How about that?
That makes sense. I would also say wind speed. I mean, all of those are elements
Beautiful.
of weather, though.
Wind
Just to be more
speed.
specific.
Yeah, and other things like pressure, sensors from the data from barometers, temperature, and all of those things. Okay, very good, very good, very good. Now another one. If you want to build an AI model that will be used in a self-driving car like a Tesla, Tesla is not fully autonomous, but let's assume there's a magical model that is autonomous. What are the features that you would use for the model that's highly predictive of what decision the model should take? The model could take four decisions: increase speed, turn right, turn left. That's mostly that's mostly all the decisions that the model takes, right? And it needs to consider a bunch of data to know that, okay, of course, it could be more than that in terms of, okay, how much angle should you turn right or how much angle should you turn left, right? But let's simplify it. Turn right, turn left, increase speed, break the speed. What are the data that you'll be using?
Distance to another object.
Beautiful. Fantastic. What else?
I'm guessing navigation system to see where traffic lights are.
Yeah, that's correct. That's correct. Lighting condition. How about that?
Yes,
there's a sensor for that, right? And camera streams, the stream of images from the camera, right? What else?
Sorry, you can also use traffic data.
Absolutely, yes. I think, I don't know who was speaking. Was that Femi? Yeah, he mentioned that as well. That's correct. Yeah, that's correct. Yeah, but so that is how it works, right? You need to go after the information that are highly predictive of the outcome that you're looking for. People that trade stocks with AI, do you know what they use? They use the script Twitter, the script Can you hear me? Hello?
Yes, we can hear you now. Lost you for a bit.
Yeah, my AirPod died. So those folks that trade stocks with AI, do you know what they do? It's as simple as, okay, understanding what moves the stock. What moves the stock? Number one, people's fear and emotion. People's fear, optimism, and emotion. Number one. So if you want to model something that that represents people's fear, optimism, and emotion, where would you get the data from? So they will go to Twitter, they will go to Reddit, and then analyze the data there to see the optimism. Everybody is talking about Nvidia, optimism. Fear, this company is going to crash or whatever. So that is that. All right. What else moves the stock price? Earnings, earnings of the company and the growth of the earnings. So now they will, you go to the record. They could compress the recording because companies are supposed to, every quarter disclose their financials. How much money did they make and all of that. So before anybody else, process the data and put it in a structured way on like Yahoo Finance and Google Finance, they would use the earning call transcript to process the model to know whether the company made more money before, because you have to do it first before everybody else. Right? You have to do it first before everybody else, or else the opportunity is gone. Right? So they use the earnings transcript, process it with the NLP, get the actual facts, how much money versus last quarter, how much money versus the same time last year, did they make? And then they use that to place a trade. Before everybody knows what is going on, they've already earned their profit, and then they will be exiting the trade off the back of people that are just, that got to the party so late. So the concept is knowing the things that are highly predictive of the outcome you're looking for and finding a way to convert that into numbers. It's as simple as that. It's as simple as that. If you can do that so well, you will create magic in terms of what you can do with AI models. Thank you so much. Thank you for joining the rerun. This is again a recap of what happened in class 2 because we lost the recording for due to technical glitches. We are doing it again so that it could be recorded and referenced on demand by other students that are not able to participate live. And thank you for joining. You can put your questions on Telegram. You can put any question that you have on Telegram, and then you will be responded to, and you'll get answers in a couple of hours once our admins and moderators, access your question. Thank you so much. If there are no any other questions, let's have a very beautiful Wednesday evening, everybody. Thank you, everyone.
Thank you so much, Israel.
Thank you. Thank you for me.
Thank you. Good night.
Thank you. I didn't get a name.
So my name is Choma.
Chuma. Okay, awesome. Yeah. Okay. Thank you, Chuma. Have a very beautiful Wednesday evening.
You too. Good night.